Conference will now be recorded.
There we go. All right, welcome to the SFPUG November meetup. I'm your host, Catherine Saar. Before we begin, the meeting is being recorded and will be posted on YouTube afterwards. Everyone who speaks during today's event will be part of the recording. We will do the Q&A at the end of the presentation. If you choose to ask a question, your voice and image, if you have your camera on when speaking, will be part of the recording. If you do not ask a question, you will not be part of the recording. If you're using the most recent version of the app, which we do recommend, you can use the raise hand function to join the queue. If you're using an older version of the app, which does not have this function, please use the chat to let the organizers know you would like to ask a question. They will add you to the queue. The organizer will let you know when you are next in the queue, so you can be ready to unmute your microphone and ask a question. If you do not want to be part of the recording, the organizers can convey your question to the speaker. In that case, please type out your question in full and let the organizers know you would like them to present it to the speaker. If you have any technical issues, please message the organizers for assistance. If you drop out of the meeting and are unable to rejoin, you can post a message on the event page on Meetup, which we are monitoring during the presentation. SFPUG, Bay Area Postgres, is a PGUS affiliated user group, and I am a volunteer for PGUS. SFPUG is sponsored by PGX, and I work for PGX. Thank you for joining us for It's All About Them Stats, Less Trouble, with Kacey Holston.
Okay.
Perfect. Looks good.
Right. Lovely. So, thank you very much for your introduction, and I am sorry for the technical difficulties there. So, it's all about them stats, less trouble. If you know the song, you know the song. I am Kacey Holston. I'm a senior DBA at PG Experts, Inc. You can find that at pgexperts.com. And I am going to be talking about PostgreSQL statistics. Those are the views in the database that tell you what is going on in the database, not your data itself, but the behind the scenes, what's going on in there. And I originally planned on talking about all of these views that have just popped up on the screen. There's a lot of them, but there's so much good information in them. And as I started on the first one, PG stat activity, I came to realize that this wasn't a talk. This was a week-long seminar that I would be talking and talking and talking for a week straight if I went through every single one of these views. This is a talk series, not a talk. And I hopefully will do that at some point. So I decided that instead of doing all of them, I would focus on a subset, some of my favorite ones, and the ones that sort of played together nicely, that sort of went from one to the other. The majority of this talk will be PG stat activity because it is a heavy duty table. It is the big daddy of stats views, in my opinion. And once I finish with that, I will talk a bit about PG locks and the PG stat progress views, which cover analyze, cluster, copy, create, index, vacuum, and base backup at the moment. I'm hoping as time goes on, we get more of those because they're very cool. I think they are very, very cool. Very, very cool. As someone who likes to know what's happening, they give you a lot of really great information. So my little elephant here is wondering what is going on with their database. There's a query, some application ran something and it's running slow, or my little elephant put in some query and nothing's returning, and my little elephant does not know what's going on. There's a lot of third-party applications that you can go to that will give you some of this information. A lot of those give you sort of big picture information, but my little elephant wants to know what's going on right now. And to do that, they're going to use the stats tables. They're going to log right into their database and go to these stats tables and take a look. So the first one, as I called it, the Big Daddy PG stat activity, is going to tell you what's running right now. it's going to give you a lot of information about what's running right now. And we're going to start talking about what information it's going to give us. What are these columns saying? So the first set is the connection information. It's going to give you the database OID and the database name. That is important because a lot of servers have more than one database running on them. Some of the hosted databases have background entire databases that has stuff running. So you want to know what database is running this query. The next is the process ID, and that is literally the ID of the process that's running in the background. The leader PID, if this is a parallel process, that's going to tell you the head honcho query, what is leading this parallel process. The user OID and the user name is going to identify who is running this query. That can be important if Joe in the office next door started a transaction and has left it running for 3 days, and you need to know to go knock on his door. Or if it's running through the application, if it's a certain user through the application, this is going to give us really, really important information. The client address and the client host name. The host name is as found through a DNS, running through DNS, and the host address is going to, of course, be the IP. That's going to tell us where this connection is coming from. Hopefully it's a connection that you recognize, you know where this connection is coming in from. And lastly, the client port, what port is being used to communicate. So this information is really important to track down what's going on and where it's coming from. Timing. There's 4 different times for each entry. The backend start is when the process actually began. So this could be if a pooler has connected and run a bunch of things and it's still connected. So these times could be, all 4 could be the same as you see in my, or almost exactly the same as you see in my example here. Or they could be vastly different because that backend could have started hours earlier. The XX start is the transaction start. That is when the transaction itself started. It could be running several queries, many queries, an entire script of queries inside of this transaction. And so that transaction could be very different than the query start, which is the next one. That's when the actual query itself started. I tend to query on the transaction start because I want to know when the whole thing started. And the state change. That is, we're going to talk about state changes in a bit, but that is when the state of the query last changed. And I should pause here for a moment because I was going to say this earlier. You may notice I pause every once in a while when I'm talking about all of this stuff, and that is because I'm trying to keep this talk narrow, and there's so many tangents that I can go off on like I just did. So please forgive me if I go off on a tangent, and please forgive me if I pause to lecture myself. Wait times is the next one. You will see the wait event type and the wait event. But we're going to come back to this because that is a book. That is a book of information. So we're going to wrap back around to that. So we said we'd talk about state. This is then. There's 5 states. The bottom 2, fast path and disabled, you will very rarely see. Fast path is a fast path function, and disabled is, well, disabled. The 3 that you'll normally see is active, idle, and transaction. Active is something is actively running. It is doing its thing. Idle is when a connection is present, but it's not doing anything. You'll see this often with a pooler when a pooler has established the connection and it's waiting to recycle that connection to have another query or transaction run on it. Or Joe, once again, down the at the back end of the office there, Joe logged into PSQL and isn't doing anything. Idle in transaction is our frenemy. Idle in transaction means that something or someone hopefully is thinking or has forgotten that they're connected. And it's our frenemy because at times it's really necessary. At times you want to query, you want to think about that information, process that information, and then come back and run another query. But it can also be bad because it can hold up things like vacuums. So you don't want to have that running for a long time. That's definitely something that you want to pay attention to when you're looking at PG stat activity. And again, another tangent I could go on, but I'm holding myself hostage here. Next is what I call visibility. That's the backend XID and the backend XMIN. As you may or may not know, MVCC is what this Postgres uses MVCC, multi-version control. And so the backend XID is the top level transaction. It's when this query exists in time of the database. The backend XMIN is the data, the horizon of the data that this query can see. So it's important to look at that information, know where it stands, especially when you've got some of those idle in transactions. Next is the query. The query is the part that you probably are here for this PG stat activity. The query ID is only going to be enabled if you have compute query ID enabled. I don't for this example. And the query is going to be the actual text of the query. It can be truncated because it only will show as much as track activity query size is set for, which oftentimes is limited. So you'll see that truncated, but it can be, you can have that be longer if you so choose. And next is backend type. This is going to tell you what type of backend is being run. You will often see client backend if this is just a query that you are running, but you may also see logical replication worker, auto vacuum, while writer, while sender. Any of these categories here can be seen there, and it'll tell you what that process is doing. Now we talked about weights. And we said we were going to come back to them. But now is the time. So I'm going to go through all of the weights. There's weight types, and there are there are weight event types, and then there's weight events in each type. A lot of these weight events types have quite a lot of weight events underneath them. If I went through all of them, we would be here for days. So I am going to attempt to pick out one or two to talk about and just more or less describe what the general category is on this. I'm going to try and make this somewhat conversational so that I don't bore anyone. But the first category is activity. And that is basically an idle server process because it is waiting on an activity from the main process loop. And I say it's idle because it is, but I guess technically all of them are. So I would be saying that for all of these. Whenever it's waiting, it's of course idle, but these are waiting for something in the main processing loop. Most of them are reasonably self-evident. You've got, for example, the recovery wall stream is waiting for wall to arrive during streaming recovery. There's logical replication ones, there's wall writing ones, but this is largely waiting for an activity. The next is buffer pin, and that is waiting for a buffer to be released. Buffers are used to store data in memory, and this is waiting for the buffer. I debated talking about what to do about this one, but if I did, then I'd have to do that for every single one. So again. The next is client. This is waiting for the application. The application is doing something that it's waiting for. So client read, it's waiting to read from the client. Client write, it's waiting to write data to the client. These are all application based or wall based. It's waiting for a client. The next is extension. You could see extension as the wait event type, and that is a little harder, only because there's not a preset, predefined set. This is extension by extension, so the different extensions will have their own module here. Injection point is, as it says, waiting for an injection point. There is not a list of wait events for this one. If you see injection point as the type, you'll see it as the event as well. The next is IO, and this is the first of our massive list of wait events. This is, as it says, waiting for an IO operation to complete. And the name of the wait event will identify what exactly it's waiting for. So yeah, this is all of them. It is quite extensive. I believe there was about 70 different ones. They're all pretty well named in this for IO, in my opinion. Copy file write means you're waiting for a write for IO operation. Buffer refers to buffer. It's all pretty self-evident. I'll give you a second to process all of those extensive names. Logical rewrite sync is waiting for a rewrite of the mappings. Quite the list. And then the next wait event type is IPC. This is waiting for some interaction with another server process. So another server process is doing something and it's waiting for it to finish before it can continue. Another wonderfully extensive list. You know, I talk about how extensive the lists are and how much data there is to know, to learn, to understand. But it's really cool if you think about it, that you can pinpoint exactly what it's waiting for, that we can get that information, that information is available to us. The more information, the better for all of this to debug, to drill down on what's going on. So these are also, depends on the process. They are a little bit more complicated though. Or some of them are, a lot of them are a little bit more complicated than IO. And so the naming is a little bit more obscure. So for example, hash batch load is waiting for another parallel hash to finish loading a hash table. Hash batch load, nice and concise wording there, but doesn't necessarily paint you the full picture. So a lot of these are good to look up, dive into, do some research into, because they may not be as obvious as some of the ones, say, in the IO category. next we have locks. These are the heavyweight locks. These are locks that are going to be on SQL visible objects, things like tables, pages, tuples. The wait events are, a lot of them are pretty obvious. Some of them less. Advisory lock, those are application defined. And so they're going to be defined by the application. I started talking before having finished that sentence clearly. The applied transaction is going to be waiting on a lock from a logical replication subscriber. So the logical replication subscriber is doing something, and we're waiting for it to finish before we can continue. Extend is waiting to extend a relation, and the rest are pretty self-evident related to the name of what they are. Next is lightweight locks. Lightweight locks are locks again, but they have more to do with the data structure and shared memory than with an actual data object. And so there's another extensive list. This may be our longest list of them all. So it could be waiting for something that's vacuuming, memory. You have buffer content, which is waiting to access a data page in memory. This is another one where there's just so many of them that I could either have the entire talk be about just the lightweight locks, or I could share with you all of the wonderful things that are available and tell you go look them up until my next talk on them. And lastly, for the wait type events is the timeouts. These are waiting for a timeout to expire. A lot of these are defined as a certain delay, as you can tell by the name. PG sleep can be called explicitly, and the process is waiting for that to expire. It could be a delay that's set for throttling or wall, but these are typically set timeouts. And that is PG stat activity and the majority of my talk, as you can tell. So much information there, really, really important information. When something's going wrong, taking a snapshot of what is happening on PG stat activities can be so valuable. And a lot of times what I will tell people to do if they notice something is going on and they can't figure it out, take a snapshot, copy that activities to a CSV file. It'll really tell us what is happening. And I'm actually surprised, the reason why I included it into this talk is I was actually surprised at the people that didn't know about this table or didn't know all the valuable information, view, and did not know about all the valuable information that is in here. So I really did want to spend some time talking about it. The next view that I wanted to talk about is PG locks. One of the wait events that we saw were those heavyweight locks, and sometimes you don't know what's causing them. You don't know why it's locked, what it's waiting on, and locks can really mess up your database. So I wanted to talk about PG locks, which is one of my favorite views. I love playing with it because I love fitting puzzle pieces together. But PG locks is going to tell you all of the heavyweight locks that are being taken. And the column I want you to first notice is granted. Granted can be true, granted can be false. If granted is true, it's been granted. If it's false, that lock is waiting. And we can use the granted true and the granted false to discover what that query is being locked against. So if you look at the top there, the lock type, you'll see what type of lock it is. So I have listed here the different types of locks you can have, the relation, page, tuple. That is the list of potential lock types. underneath that, you'll notice that same list is repeated. And since it's a relation type lock, we have a relation number, and that's going to tell us what relation is being locked. If it was a page lock, you would see a page there, tuple, and so on and so forth. So now we can find everything, every lock that exists on that relation, which is what I've done here in this example. And we can see which one has been granted and which one has not been granted. We can see what kind of lock, sorry, my big screen is over there. It's hard to see on my small screen. That's why I keep on looking to the side. You can see what kind of lock we have there. Here, we've got an access exclusive lock being held, and we have an access share lock waiting. We can also see how long it's been waiting for. So super, super useful information. Definitely suggest using PG locks as much as you need to. Now, that takes care of our heavyweight locks. That drills down into that. Now, what if a query has been running for a while? We check PG stat activity, and it is active, but it's been running, and we want to know why. We want to know what it's doing. That is where our PG stat progress views come in. And I love these. I wish there was 5 trillion more of these because they are just so helpful. Especially someone like me who just wants to know all of the things that are happening. Some people call it nosy. I call it inquisitive. PG stat progress analyze is one of them, and this is the information you can discover if you're running an analyze. You have the database that it is running on. You have the relation that is being analyzed. You have the process of the analyze itself. You have, lost my place. You have the phase that it's on, and I have listed here all of the phases that you can, that it will go through. This is the order, so it's really cool to know exactly what an analyze is doing. You just press the button, go analyze this table and get some stats, but what is it doing to do that? This goes through each stage that analyzes run through. Underneath that, you have total and you have completed. So either scanned or computed or done. And it's going to tell you how many are expected to complete, how many it's running, and then how many it's done so far. This is a very small number, 211, but you can see how when those numbers get much bigger, how useful that information would be. Next, we have PG stat progress create index. And this one obviously is run when you're creating an index, but it is for reindex, it's for index concurrently, and it has right in there the command, so you can see exactly what was run when this is being done. It has the phases again, it has all of the data information, the relation. It also has the index OID. Again, everything that is expected to be done, everything that has been done so far. It also has the phases. You'll notice that some of these have a lot of validations. These are skipped if you have not chosen concurrently. So those are only done for concurrently. And so you see a lot of waiting, which is why they take longer. But it also means that you don't have that locking. Next is PG stat progress vacuum, very similar to analyze, except for, of course, this is vacuuming, so has its very own phases. each one goes through and does its job and reflects what it's done in the heaps, the heap total, scanned, and vacuumed. So each one of those will show up as the phase completes. Next is PGStat progress cluster. This is for cluster, but it's also for vacuum full. This is where you'll see your vacuum full progress, and you'll see that's exactly what it is that I ran here. This one will also tell you how many, it'll tell you, sorry, I'm getting myself confused here. It will tell you the number of indexes rebuilt, and it will also show you the writing of the new heap and the swapping of the files. And PGStat progress copy. If you saw my talk last year, you'll know that I'm a big logical replication person, and I love this view. This view is my baby. I check it all the time during that initial copy to make sure that the tables are increasing, that there's been no errors that have reset the table copy. I use this one a lot for that, to see how much has been copied over, give me some sense of where it is in the copy. This one is a really, really big one for me. And it shows you the command, but what I think is cool about this one too is it not only shows you the command of copy to, copy from, but it also shows you the type, which is it being copied to or from a file, a program, a pipe, a callback. So it has all of that information for you, as well as what's been skipped, if there's, or excluded. So a lot of really important information here as well. And I managed to keep this at exactly 30 minutes, which was my goal. So it's my very, very last slide to see if there are any questions my little elephant would like to know.
Do we have any questions? That was a great talk, Kacey. Lots of information there, lots of really good information. Yeah. And I think you should consider doing that seminar. That would be like, I think that would be well attended. All right. Last call. Any questions? Anybody? No? Okay. That's fine. All right. Thank you again, Kacey. That was a great talk. Thank you to PGUS and PGX. Our next PUG will be on December 9th, and we'll be presenting What's New in PostgreSQL 18 with Christoph Pettis. And an upcoming conference, the next one is PG Day Dallas, February 19th in Irving, Texas. The CFP is currently open through the 30th of November, so if you are interested in giving a talk there, now is your chance. We will send a link by email when the video is ready, and you can watch our social media. You can find us on LinkedIn, Mastodon, and Blue Sky by searching for Bay Area Postgres. We are looking for speakers for 2026. If you or someone you know is interested, please contact us through Meetup. Thank you, everyone who attended. Hope everyone has, a great month, and we will see you back here on December 9th. Thanks so much. Bye-bye.